Our first speaker for this morning is going to be actually Eric Stanley. He's a developer for Nagios.
Thank you. Well, good morning. I hope you guys are enjoying the conference. I know I'm enjoying it. I'm actually having a lot of fun talking to a lot of you about what you guys are doing with Nagios in your environment. So it's been good for me to hear that, to hear the things that you're doing and some of the things on your wish list. So I'm enjoying that. Trust it's going well for you as well. I wanted to introduce myself a little bit before I get started with the topic for this morning. My background is in software development. Spent about the first half of my career doing that. I learned C when I was in college and wrote my first significant program in C. Spent a lot of time as an embedded software developer. So one of the things that I learned was the importance of good algorithms and good data structures for writing code that runs well. And even though I didn't do most of the work on Core 4, you'll see the fruits of that as we go through this today. Then like I said, about a dozen years into my career, I kind of switched focuses more into the IT side of things. So today I wear two hats. I work as a system engineer for a company, and then I also work with Nagios as a developer. I work primarily on the C code stuff, so Nagios Core, NRPE, NSCA, NDO utils. Those are the sorts of things that I primarily focus in. I do know other programming languages. I'm pretty proficient in Perl, know a little bit of Ruby, and I'm picking up JavaScript. So anyway, that's a little bit of background about me. Let's quick overview of Nagios Core 4. Nagios Core 4 was released just about a week and a half ago, Friday the 20th. But development work actually began back in June of about 2012. And I have to give much credit here to Andreas Eriksson. He was the primary developer on this. Andreas, are you here? I don't see you.
No, he's going to be here in a minute.
Okay. Well, when he gets here, we'll make sure to thank him. And if you see him, he's here at the conference, so make sure you thank him for all his hard work on Core 4. The first primary change in Core 4 is actually in performance. Most of the changes in Core 4 are under the covers. You won't see a lot of changes in terms of configuration, not much in terms of the user interface. Most of it's under the covers and a significant increase in performance. And that increase in performance comes from four primary areas. The first one being core workers. Core workers are a lightweight process which perform a simple task, mostly host and service checks. And I've actually got a couple slides on core workers a little bit later on. The second area of improvement is in configuration verification. One of the tasks that Nagios Core does when it starts up is it verifies the configuration that you send it. And it used to be that as your configuration, as the number of objects you had grew, the time that it took to verify those objects grew as a square of that number. Now it's a linear function, so configuration verification happens much more quickly. The event queue. The event queue is used for lots of things in Nagios. Anytime you schedule a check, anytime you have downtime, you want to do a freshness check, you want to expire downtimes or comments or anything, all of that stuff goes into the event queue. So you can imagine in a large installation, you're going to have a lot of things going into the event queue. Well, Andreas has taken that event queue and optimized the insertions so they're now much faster, meaning that the CPU necessary to process those events is much less. And then the fourth area is macro resolution. Macros are now sorted on startup so that you can do a binary search on them, which is much faster than the old method, which was a linear search through the entire list of macros. And there are also special case for frequently used macros, the arg macros, the user macros, and the host address macro. You imagine the host address macro is used for practically every check. So those guys get special case early lookups. Those are the four things, the four primary things that have contributed to the increase in performance in Core 4. Bunch of new features in Core 4, again, mostly under the covers, but one of those is the query handler. The query handler is a way to communicate directly to the main Nagios Core process. It uses a Unix domain socket, and that's the location of that socket, the default location. So if you just untar the core tarball, run configure and make, and run it, that's where it'll be. It uses a simple protocol to communicate with the query handler, the name of the query handler, and a command, and then any other arguments. And I will actually put in a little bit of a shameless plug for a talk that I'm doing this afternoon, 2 o'clock, track 2, where we'll be giving a little bit more in-depth demo of the query handler. There are 5 query handlers that are built into Core right now. The Core query handler simply provides management and information about Core itself. The wproc query handler is what the worker processes use to register themselves and tell Core, hey, I'm out here, I can do some work for you. They use the query handler interface to do that. NERD is the Nagios Event Radio Dispatcher. You can subscribe to different channels on using the NERD query handler, and it will then report information to you. So for example, you can subscribe to the service checks channel, and it will report every time it does a service check, the name of the host, the name of the service, and the state that it was in before the check, and the state that it transitioned to after the check. And I'll demonstrate that a little bit this afternoon too. The help query handler basically provides help for the query handler subsystem. I don't remember if there are any commands other than list, help list, which just lists all of the registered query handlers. So if you want to know that, you can do that. And echo is a very simple query handler that just simply echoes back what you send to it. Primarily just for testing, make sure things are working the way you want. So that's the query handler. That's one of the new features in Core 4. Most people aren't going to interface with it, but it's good to know that it's there and how it's used. Okay, let's talk a little bit about core workers. One of the things, let me give you a little bit of background about what Core does to help you understand the benefit of core workers. So Core itself does, first thing it does when you start it up, it does a whole bunch of initialization. We talked about the fact that it does the configuration checking. It starts the timing, the event loop, does a bunch of other things in the background. If you're restarting and you had a retention file, it reads the retention file then. All of this stuff happens on initialization. Then there's the whole scheduling piece. Talked about all the things that need to go into the event queue: service checks, host checks, freshness checks, downtimes, downtime starts, downtime expirations. All of that goes into the scheduling. Then the other thing that the Core used to do, or Core does, it still does, is it initiates host and service checks. So it says, hey, it's time to do a service check, let's go do it. And then when the service check is done, it grabs the results, updates its internal view of your environment. Handles downtime. So if you're in a downtime and you run one of these host or service checks and it reports a problem, it has to know that you're in a downtime so that it can not send out notifications as appropriate. Or if you're not in downtime, then it also sends out notifications. Another thing that it does, processes external commands. So you can see there's a lot of things that Nagios Core has to do. So in Core 3, whenever you performed a check, the Core did several things. First of all, it would fork itself or make a copy of itself. In fact, it would do that twice for every check. So it's taking all of that code, initialization code, scheduling code, downtime code, making a copy of it in memory, and then it would actually fork again to perform the check. Well, there's a lot of stuff in Core that you don't need to perform a check. You're not doing any scheduling. You're not checking for downtime when you're actually performing the check. The Core does that after the check results come back. So that was one area of inefficiency. Another area of inefficiency was that the check results were written to and read from the disk. In fact, what happened was when you did that first fork, it would write out partial check results, information about what the host and service that it was actually going to check, perform the check. Then when those results came back, those were written to the file. And then there was a Reaper process in Core that would periodically go out and look at a directory and say, oh, have I got any check results that I need to process? Anybody that's worked in any time in IT knows that the slowest part of any computer system is the disk I/O. And so this was a bottleneck that was in Core 3, and it no longer exists in Core 4 because of the introduction of core workers. So what a core worker is, again, it contains only the code necessary to perform the task. So it doesn't contain all that scheduling and initialization and all that code. The other thing that's true now is that the core workers are only forked at Nagios startup. Not every time a host or service check is run, they're only forked once when Nagios Core starts. The other thing that's true is that now if you have simple plugins that you're executing for your checks, it doesn't need to fork again. It just runs those checks directly. The other thing now that's also true is rather than writing the check results to the disk, they are passed back to the main Nagios process in memory. So memory is, reading and writing from memory is orders of magnitude faster than disk, even if you're using fast disk like flash technology. As I mentioned earlier, workers register themselves using the query handler interface. One of the things they do when they register is they can specify what kind of checks they want to run. Now, the default workers that come with Core 4 don't specify that, but it does mean that there are possibilities for specialized workers. So, for example, today when you do a ping check, what generally happens is you actually call bin ping or user bin ping or wherever it is located on your system to run that. If you really wanted to optimize the ping check, you could write a specialized worker that sent the ICMP echo request out and listened for an echo reply. Now, would you gain much efficiency from that? Probably not, but that's an example of what you could do in terms of a specialized worker. The other thing that core workers give us is a couple of future possibilities. I've got a couple down here that are suggestions. They're kind of related, but remote workers might be one thing. So if you want to offload some of your checks, you could actually start up a worker on another system, have it register over the network. Today that's not possible, but it could be possible in the future. And say, I'm going to do checks for this machine or this subnet or something like that. That's one of the possibilities with core workers. So I think, in my opinion, core workers are probably the biggest change in Core 4. All right, let's talk a little bit about, there are some object changes, a few things. One of the new object attributes is the hourly value attribute. You can put an hourly value on either hosts or services. And the hourly value is intended to convey the value of that particular host or service to your organization. It's just a simple integer value, so it's not necessarily dollars. It could be, for example, it could be number of people impacted by the host or service. You can use it for whatever you want. Here's an example. A development server would probably have a low value, but your production e-commerce web server would have a high value, and you'd want to know that. Related to hourly value is the minimum value. Minimum value is a new attribute on contacts. And if the hourly value of the host or service that you're checking is less than the minimum value of the contact, that contact would not be notified of a problem with that host or service. And it's important to note that the value of the host is the host's declared hourly value plus all of the hourly values of its services. So example, system administrator might want to know about that development server that's running out of disk space, but you certainly wouldn't want to tell the CIO that. So you could set a low minimum value for a contact that was a sysadmin, and if you had a CIO that wanted to know about this sort of stuff, you'd set a high value so he or she would only be notified of issues with high value objects in your environment. I actually thought of kind of an interesting application of this too. If you're a really good sysadmin and you have lots of uptime, What you do is you take your availability report and you multiply that availability time by the hourly values, and you can show the company how much you're worth to the company. Of course, if you're a bad sysadmin, you want to stay away from that. All right, another object change. Service parents. Service parents are the service analog to host parents. Not quite the same thing, but pretty close. And the host parent was intended to show sort of network relationships between hosts. So to get to this host, you go through this one and this one. Whereas service parents are more of a simplified version of service dependencies. The example I've got here is if you're using SSH to, for example, check space used on disks. You might make the check SSH check, the one that says, hey, can I talk to the SSH port? The parent of these check by SSH checks, so that if SSH is down, you're not getting notified, hey, your root disk is unreachable, or its state is unknown. Another change, host attribute address. It's now optional. I actually think that's been true for a little while because I've been using it that way, but it wasn't true in the documentation. So now the documentation is updated and it's officially optional. When you don't have it, it is set to the host name and when it's missing. And most people don't use IP addresses in their host objects, at least as far as I know, and that's the reason for that. There are two objects here, the obsess over host, which is an attribute of a host, and obsess over service, which is an attribute of a service. Now support the shorter attribute obsess because the host and the service were redundant. And then finally, the failure prediction enabled on hosts and services has been removed. Failure prediction was never really implemented, so it didn't make sense to have it. A couple of changes in object behavior, things to know about. So contact inheritance. The documentation has for a long time said that if a service has no contacts, it inherits contacts from its host. But if it does have contacts, it doesn't. Well, that didn't quite used to be true. It used to be that if a service had no contacts but had contact groups, it would still inherit contacts from the host. It's been changed now so that if a contact has any contacts, whether from contacts directly or contacts groups, it does not inherit from the host. There's been some problems resolved with time periods when the time period included both exclusions and exceptions. Okay. A couple of changes to configuration. Core 4 is beginning to get to the point where there's a lot of ways to get information out of it, and not just through the status file and the object cache file. So if you're in a large environment where those things are slowing you down, you can, in the main configuration, set values for status file and object cache file and or object cache file to dev null, and Nagios won't write them out. A little bit of a caveat, if you're using the CGIs, they still need those files. So you want to leave them enabled. There's a new option, log current states. So whenever, in Core 3, whenever logs were rotated, the system would log the current state of all hosts and services at the beginning of that log file. The reason for that being that if you're doing, for example, an availability report and a host hasn't changed for a long, long time, you might, if you didn't have that information, you might not know what state it was in at the beginning of your availability period. This enables you to disable that, and in large environments that can save you disk space and time when log rotations occur. The two parameters that are specific to the workers in the query handler, the quick check workers allows you to specify the number of core workers that are started when Nagios starts. You can leave it blank and it will calculate a number based on the number of CPU cores on the system. Andreas, correct me if I'm wrong, I think it's 1.5 workers per CPU core with a minimum of 4. So that's one option. The other option related to query socket is just the location of that query handler socket. So if you don't like it and use your local Nagios, you can move it. Enable environment macros is another new option, which determines whether or not the macros are exported to the environment when you run a command. So previously you could, this at least if you're not using large installation tweaks, which is a different case, but all of the macros were exported to the environment. Well, if you have a large installation, that can chew up environment space. So you can say, I don't want to export these to the environment. Now you can still use them because you could pass them as command line parameters to whatever command you're running, a check or whatever. So that's still a possibility, but you can save some environment space by disabling that if you want to. Another change is that all of the paths in the main nagios.cfg file can now be relative to the location of that file. So if you're in an environment where you have some test setups, so you have multiple configs for different test setups, you can simply have Nagios config at different locations in your directory tree, and then all of the files can be relative to that. Two variables that are deprecated are the check results reaper frequency and max check result reaper time. Check results are no longer reaped. They are fed back to the main Nagios Core process as soon as they're received by the core workers, so these have no effect anymore. And then finally, object definitions. It used to be permissible. I don't think this happened very often, but it used to be permissible to define objects directly in the nagios.cfg. So if you wanted hosts in there or time periods or whatever, you could do that. Now that's explicitly prohibited. You need to put them in a file that's included in the nagios.cfg file. A couple changes in macros. There's a new macro called check source that contains the name of a worker that performed a check. So if you're having issues with checks, you can make sure that you've got, for example, if maybe you're using specialized workers, you can make sure that the specialized worker is actually the one performing the check. A couple other changes. If you have the use large installation tweaks set, the host group members and service group members macros are no longer exported to the environment. In large installations, those can be quite large, and you can fill up environment space if you do export them. We talked earlier about the enable environment macros, whether or not macros are exported to the environment at all, and then also some of the macro-related performance enhancements. All right, some miscellaneous things. Andreas has developed libnagios. Libnagios contains, I don't know, 8 or so components that are used to support the workers and would be used by somebody if they're writing a special purpose worker. All of the code for libnagios is in the lib subdirectory off the main the Nagios source code root directory. Some documentation updates. Doxygen formatted documents are now available. If you run make docs from the root of the Nagios distribution, it will make a documentation subdirectory. Contains HTML documentation with interesting things for query handlers, worker processes, and some of the code. Good deal of effort has been put into the test suite, so we can test things and make sure things don't break. Excuse me. Excuse me, Nagios spec file has been significantly updated to bring it up to current RPM standards. Thanks primarily to Dan Wittenberg for doing that. And one thing that is primarily only of interest to developers, each object in as it resides in memory in core right now, has a unique ID. However, it's not persistent across restarts, but it is something that can be used to access objects more directly than just by name, which is the usual way of accessing them in Core 3. Let's talk for a few minutes about some deprecated features. The extended host and service information objects, that information has been available in the primary host and service objects for quite a while. So now they are officially deprecated. The -X option, the one that tells you not to check for circular paths, that's related to the optimizations in, in the configuration checking. So it's not really needed anymore. I think the largest configuration that you tried to check was probably, what, 3 seconds to process now? Okay. Okay. So we figure 1.2 seconds is, you know, for a system that size, is a reasonable amount of time to wait. We've discussed some configuration variables that are now deprecated. We talked about the Reaper variables there. Sleep time, I'm trying to remember, sleep time I think is the amount of time that Core would force sleep between checks. Because checks are fed back immediately, that's no longer necessary. And the last two here are the external command buffer slots, command check interval. Those are related to processing external commands. The way things used to work is that when an external command came in, it would be written to a slot, and then Core would periodically query to see if that's there. That's no longer the way that works. They're read in immediately. So those two variables are no longer needed. Obsoleted features. Embedded Perl. I hope we don't hear too many cries of anguish with the disappearance of embedded Perl. Primary reason for removing it was because it was probably the most problematic part of Core. And not so much because it was Core or Perl, but because the number of permutations of versions of those two things was quite large, and you could never quite tell where the issues were. We believe that the speed improvements as a result of the Core workers and other things, improvements in Core 4, would mean that embedded Perl is no longer necessary. However, if you really love it, we certainly will welcome patches that would contribute an embedded Perl Core worker. That is a possibility with the new Core worker architecture. Another obsoleted feature, we talked about failure prediction. It was never really implemented, and in fact it would have broken the Core paradigm, where Core doesn't really care about any of the performance data that comes back with check results. It would actually have to have known about that information or remembered it, so it didn't make sense. We got rid of it. The other thing that's been obsoleted is the -O option. I don't remember whether this was even advertised in Core 3, but you could still use it. It was deprecated in 3. Never didn't do anything, so it's been removed completely from Core 4. All right, so if you want more information, a couple of places you can look. Nagios Core documentation up there on SourceForge. That's been gone through and updated for Core 4. Primarily, you want to be looking at the What's New page. What's New page contains most of what we talked about today. But if you need to go back and review that, you can certainly look there. And then elsewhere in the documentation where new items were introduced, I tried to highlight those with the green font so you could catch them easily, and anything that's deprecated, highlighted in a red font. I mentioned earlier the Doxygen documentation. Simply run make docs in the root directory of the distribution, and that'll generate that HTML documentation for you. And then finally, there is the source, Luke. Feel free to use it. I know not everybody's a C programmer and enjoys reading C code. Worst case, if you're not good at that, it's a good cure for insomnia. Let's see, I think this is this next slide that I wanted to show you that's kind of fun. We had somebody post to one of the forums last Tuesday with some interesting results. This is a graph of their CPU load as they're upgrading from Core 3.4 to Core 4.0, running 2,300 host checks, 4,500 service checks. It's a 24-core system with 32 gig of RAM. And can anybody tell what time they actually did the upgrade? So I thought that was really cool, and I was impressed by it. So their thanks go to a lot of people. I mentioned Andreas. He's here now. Andreas, would you stand up? Andreas did the lion's share of the work on this, and we owe him a debt of gratitude for the work he's done on that. Thank you. The rest of the names in here, I just basically grabbed the Git logs to see whose name was mentioned and listed the top 7 or so. So hats off also to Dan for all of his work, especially in the area of testing. And he did me the favor of reviewing the documentation too, so thanks, Dan. All right, any questions? I think they want you to use the mic for questions, so we'll have to wait till it gets passed around.
I've made a pretty significant investment in using things like event brokers, like ModGearman. We're using the installation tweaks, the large ones, and Reaper frequencies and embedded Perl. Am I going to have to stay at 3.5 for, forever, and just toss it all out if I want to go to 4?
Well, I can't speak to ModGearman because I don't know its particular state. Maybe somebody else can, but I don't think so. I mean, the rest of those things, you probably will still see improvements in Core 4, even though you got those finely tuned for 3.
Okay. Okay, thank you.
I'll repeat that for the sake of the recording. Andreas said that ModGearman has been ready for Core 4 for about a year now, and it also still has embedded Perl support, so that's a possibility there.
So you kind of flashed by it quickly. I'm not quite sure what the end state was. Are external commands no longer allowed?
Oh no, they're still allowed. They're just handled differently.
Okay, okay, thanks.
Other questions?
Any additional questions?
So you mentioned something about, I guess, certain plugins can be executed directly as opposed to forking execute. Are there any guidelines on how to author a plugin that behaves that way?
It's basically if the command to run the plugin contains any shell meta characters, then you have to fork a shell in order to interpret those meta characters. There's one more over here.
How bad will the upgrade process be? For those of us who use packages, can we just upgrade the package and expect it to work?
I would assume so. I have not done that myself. I don't know what this particular customer that showed their change was doing. I kind of assume they probably just, because there was no downtime or very little downtime in that graph, I assume they probably just compiled and did a make install and restarted. But I'm assuming that package installation should be pretty straightforward. It's really, oh, Dan, you want to address that?
Yeah, for the most part, your upgrade should just work. If you don't change your configs, you'll get a bunch of warnings about deprecated options. But for the most part, when we overhauled the spec file, the RPM was originally based off of DAG's code and overhauled with a bunch of new stuff in it, especially the new RC scripts and stuff. But for the most part, you'll just get a bunch of warnings about deprecated options and stuff, but it should just work.
I think there was one more question. Okay, sounds like no. Thank you, guys.
All right, put your hands together one more time for Eric Stanley, ladies and gentlemen.